This is number 10 in our exam 2 review, where we're given a sector of a circle that has a radius of 9 inches with a central angle of 56 degrees. We're asked to find the length of the arc and the area of the sector. Well, we've learned that arc length is denoted with the variable s, and it's determined by taking r times theta. But remember, this formula, your angle measures must be in radians. So we're going to need to multiply this by pi over 180 to convert it to radians. Okay? When we simplify that, we end up with 14 pi over 5 radians. So now when we go to find the length of this arc formed by this sector, we would take the radius, 9, multiply by our angle measure, now converted to radians, 14 pi over 5, and we end up with 9 over 1 times 14 pi over 5, and that gives us 126 pi over 5. And if we want the answer to be exact, then we would say that that is the exact value. If we want to round that to, say, the nearest tenth, we'd take 126 times pi and divide by 5, and we end up with our arc length equal to about 79.2 inches. Sorry, I goofed. 9 times 14 is not 126. 9 times 14 is 56. I caught my goof because I knew that 79.2 was just way too long for this small circle. So when I take 56 pi and divide that answer by 5, I find that this arc would have a length equal to about 35.2 inches. We're also asked to determine the area of the sector formed, and once again we've got a formula for the area of a sector, again when the angle measure is given in degree, or in radians, So we're going to need to make sure we've converted to radians first before we use this formula. And that's 1/2 theta r squared. So in our case, it would be 1/2 times 14 pi over 5 times 9 squared, or 81. You can take top times top and bottom times bottom. And then divide the top answer by the bottom answer, and we find that this area is about 39.6 square inches.